So when looking at condensation polymers, there are two types. One type is a polyester, which we have looked at in another video, and in there you have the ester linkage that looks like that. So all polyesters will have that ester bond present in them. When it comes to polyamides, which is another type of condensation polymer, now the linkage is actually an amide linkage, which looks like that. So all polyamides will have this amide functional group present in them. Okay, we're going to focus on polyamides in this video. There are two ways of making polyamides. One is where you use one monomer, and that monomer has both functional groups in there, so it's two different functional groups in them. The other way is by using two different monomers. Each monomer has its own functional group. Okay, so let's look at the first one, where we have one monomer with two different functional groups. Okay, because you are making an amide linkage, and you're making an amide bond, you need to have a carboxylic acid on one end, and you need to have an amine on the other end, because the ester forms between an amine and a carboxylic acid. Okay, and hopefully you can see that what I've actually drawn here is an example of an alpha amino acid. Okay, an alpha amino acid is where you have your central carbon that is bonded to a carboxylic acid, an amine, a hydrogen, and an R group. I've just chosen methyl to be the R group. You don't need to know these examples specifically, you just need to know how to form that polyamide. So because this monomer has two functional groups in it, it can react with another molecule of itself. So I'm just going to draw the same thing out again. Like that. And when we form an amide, we are going to have to release a water molecule, and hopefully you can see that the water molecule will release here when the carboxylic acid reacts with the amine part. So I'm just going to go ahead and draw the polymer that forms. I'm going to do it underneath. So we've got our amide bond here. Like that. Okay, so yep, we've got our amide in the middle here, that's joining those two monomers together. Remember, either end you should be able to pick up the entire unit that you've drawn and put it next to that to form another amide link over here. So over here you need to have the nitrogen coming off at one end, and you need to have your carbonyl coming off at the other. Okay, and obviously in this process we've also released a water molecule to make that amide bond in the middle. Just bear in mind I have drawn two repeat units here. If you just want to see what one repeat unit would look like, I'll do it over here. Okay, so one repeat unit looks like that. I've just drawn it over here so you can see the amide linkage that forms between them. Okay, I'm going to do another example, and this is something that you can see done on an industrial scale. So this is to make one type of nylon, and I'm going to be making nylon 6 in this one. Okay, to make nylon 6 you've got to have this monomer, 2, 3, 4, 5, 6. So you have your carboxylic acid on one end, you have your amine on the other. The reason this is called nylon 6 is because, as you can see, this chain here has 6 carbons in it, and therefore this is called nylon 6. You just need to have lots of this monomer. So if we do this reaction between another molecule like that. So you are going to form a water molecule when the amide bond forms over here, and therefore nylon 6, which I will draw here, is this molecule here. So this over here is nylon 6. Okay, you've got your amide bond in the middle here. Okay, and then make sure at either end you technically should be able to connect this end to that end to form another amide, and obviously you're releasing a water molecule in this process too. Right, let's now have a look at the other type of polyamide that we can form. So this is the one where we have two different monomers. So you have two monomers and each has a different functional group. Okay, so I am just going to go for this example. 1, 2, 3, 6. And so you've got this one monomer has amines at either end, and so that means your other monomer needs to have carboxylic acids at each end. One, 2, 3, 4, 5, 6. Okay, so you can now have an amide bond form through the removal of a water molecule, so one hydrogen here and that there. So you can now form your amide, your polyamide, which should look like this. 3, 4, 5, 6. Like so, and this molecule here is known as nylon 6. Reason being is because in both of these monomers, so this one over here had 6 carbons in it, this one over here had 6 carbons in it, so therefore this is an example of nylon 6,6, each 6 belonging to the type of monomer that made it. Okay, and obviously you release a water molecule as well. Just remember that amides can be formed by the reaction of acyl chlorides with amines, so it doesn't have to be a carboxylic acid. So essentially, if I used a diacyl chloride here, so if I just replace that with Cl and a Cl here, I would still get the same polymer. Okay, it doesn't affect that. All it affects is the water molecule that's released. Instead of water, it is a hydrogen chloride molecule that's released. Okay, so just remember you can use diacyl chlorides here. Even when we did it with the amino acids, you could have used an acyl chloride in that monomer as well.